Yeah, good day, guys. Today we are going to be looking at another example of Taylor's series method. Today all will be quite, it might involve some other one other topic again. We have to integrate in this particular one and some other things, but in the long view, it is quite easy. I will try to explain it as easy as I can. Okay, so our question says explain Taylor's method. Sorry, not explain. Employ Taylor's method to obtain approximate value of y at x equal to 0.2 for differential equation dy dx is equal to 2y plus 3 exponential x, and our initial condition to be y of 0 is equal to what? 0. Compare the numerical solution obtained with the exact solution. Okay, Mr. Taylor, let us show some breast. Okay. So the question is asking them, demanding for us. They are telling us that when we use Taylor series to get the corresponding value of y when x is 0.2 using our Taylor series, we should also get it. We should actually integrate this guy, get his actual function, and then substitute our x into that value to get our corresponding y value. First, let's do the one we know how to, we are sure, and we have been learning all this while. The Taylor's method, we can solve that one. Let us do that. So when we do the Taylor's method, remember our initial condition is that our y is 0 when our x is what? 0. We got this from this statement here. Y of 0 is equal to what? 0. So we know this, and okay, now we're going to be doing this the fourth we're going to be stopping at the fourth approximation. So right now our Taylor's series formula, we have y of x, or x in this case is 0.2, is equal to y which is our initial y, we know that, plus x minus our initial x denoted with a naught or a 0 underneath to indicate the initial sign. Okay, not all over this thing around. Then multiplied by our first derivative, and then we add it to all this squared times our second derivative all over 2 factorial plus x naught 3 triple prime all over 3 factorial plus x minus this naught 4, then 4 to factorial. Now, like the previous ones we'll be solving, one of the major things that we don't have here is our derivatives. Though we have this, but we still need to substitute into this formula to get its value. We don't know this, we don't know this, we don't know this. So let us solve for that. So our y prime was given to us to be 2y plus 3 exponential raised to power x. And then we said that our initial conditions are 2 times 0 and then 3 exponential 0. Anything raised to power 0 is definitely 1. So we are having 1 times 3. So our answer here is what? 3. Now moving over to the second derivative, where we differentiate this guy with respect to x, we're going to be having 2y bar we're differentiating with respect to x and not y. If it was with respect to y, our y will be going off. So with respect to x, we'll be having 2y bar. And the next one with respect to x, we'll still be having 3 exponential raised power what? X. So when you differentiate your exponential, you still exponential x, you still have what? Exponential x. Only when it will change is when your power is maybe having a minus or another constant in front of it or stuff like that, then something will change. But since it's just exponential x, nothing changes, it remains like that. Now we substitute our values. We know that our y prime, we've got it to be what? 3. We add this to our 3 raised to power what? X, which is what? 0. Definitely here we're going to be having, this is 2 times 3, which is what? 6 plus 3, which is definitely going to give us what? 9. To the third derivative, we're going to be having 2, differentiate this guy again with respect to x, we're going to be having double bar plus 3 exponential x. In our values, we have 2 multiplied by 9 plus 3 exponential raised power 0. Our 2 times 9 is what? 18. And we add it to our anything raised power 0 is 1, which is 1 times 3, which is 3. So we are going to be adding to our 3. Actually, we are going to be having our answer to be what? 21. And for the fourth and final one, we're going to be having 2 triple prime. Why is it triple prime? We're differentiating this guy with respect to x. So we're going to be having triple prime. That's representing our third derivative. Okay. Now we add this to this. Remember, like I've said, the reason why this is not changing. Just know that when you are having exponential raised to power x, nothing changes. When you differentiate and integrate, they remain the same. Okay. So this is your, and substituting your values, you have 2 times 21 plus 3 exponential 0. Everything is going to be giving you 42 plus 3. And definitely it's going to be giving us what? 45 as our answer. So if that's the case, we have gotten our distance, so we can now kind of write this down here somewhere around here. Math is quite easy for those who believe. Yeah, math is quite easy. Just whenever they are doing a particular thing, try to take it serious, because when we normally study maths, we normally do it for the sake of just getting that particular grade and getting out of there. But the truth is, so long you have other classes in front, you're actually going to be making use of the particular topic that you just studied today. So every single the educational calendar has been scheduled and conditioned in such a way that every single class is kind of, you also make use of the previous one you left. So you don't just throw everything away. That's why it's really good if you can't actually kind of keep in your head every time. It's not possible to have everything in your head every time. There's no tendency of forgetting some things. But at least when you have your notes, at least you can make more, you can refer back to it. So this particular question, when I saw it, I was like, was it solvable? Because I don't actually know how to integrate that. But I remember that we were once taught in our 200 level, so how to make how to refer back to my notes for me to understand how to integrate that. But we'll get to that. It's quite easy. It's quite an easy step. So using our Taylor's method, imputing our values here, we're going to be having, first of all, I just want to update our formula. That's all I'm doing now. I'm not solving yet. So y of what? X is going to be, we say that our y, initial y is what? 0. So we have 0 plus. So for this guy, our x naught is what? 0. Okay, so that means this is off, this is off, this is off, and this is what? Off. Now inputting our values, we are going to be having x multiplied by our y prime, which is what? 3, and we add it to our x square multiplied by our what? Double prime, which is what? 9 over 2 times 1 plus, this time around, x raised to power what? 3, our what? Triple prime, which is what? 21 over 3 times 2 times 1. And finally, this guy, this is 45 over 4 times 3 times 2 times 1. Okay, now finally we have that our y of x can be written as, this is 3x plus, this is 9x squared over 2 plus 21x cubed over 6. Something can cancel out here. When we just choose up with that, nothing spoil. 45x raised to power 4 over 24. Okay, now we have finally reduced the whole of this blah blah to this. So let us rewrite this. Okay, so now our y of what? 0.2. So we're looking for when our x is now what? 0.2 according to the question. What is our y going to be? Our y is going to be 3 multiplied by 0.2 plus 9 multiplied by 0.2 square over 2 plus 21 multiplied by 0.2 cube over 6 plus 45 multiplied by 0.2 is power 4 all over what? 24. Now solving that, we have with a calculator, right? With a calculator, right? Why will you use? So after solving with my calculator, you're free to pause the video and try it yourself. I got approximately, in fact that my final answer was 0.811. It was the exact answer given to me by my calculator. So this is the answer we got when using Taylor series to get the value of the corresponding value of y when x is what? 0.2. So our y is 0.881. Allow me to clear this. So you can also say using Taylor's our y is 0.811 when our x is 0.2. 0.2. Now we have done this with what Taylor's series. But the question is also demand that we compare the numerical solution obtained with the exact solution. So we are going to be integrating this guy, getting the value of y, like getting it the value form of y is equal to something something of x. Yeah, in that form. So we have to integrate that and substitute our value of x to get our y. So we have done this with Taylor's series, and this is what we have gotten. So let us check how accurate Taylor's series can be. Now, to integrate that, first of all, everything that has y in it, move it over to the left hand side, and we'll be having something like dy dx minus 2y is equal to 3 exponential what? X. Now, allow me to rewrite our friend here to be y prime minus 2, okay, y is equal to 3 exponential x. Okay, now the first step we're going to be taking here is to find what we call the integrating factor, which is just first of all, before I rush into that, like I said earlier, we have to move everything that is having anything y at the right hand side over to the left hand side, and we did that from this equation. We did that and we got this, and we also rewrote just this front guy to be this and this are actually the same thing. Now okay, we have succeeded in writing this in this form. We have decided this is how it should look like. Before, if this is going to confuse you, what we are actually interested in here is just the px. So that was the reason for us moving everything that's having y to the left hand side. So in this case, our px, if we are to compare these two equations together, we have that our px is what? Minus 2, and our qx is what? 3 exponential x. We just want to compare these two, and we have gotten this to be this. So the integrating factor, its formula is normally represented with an Euler sign. Its formula is given as the exponential raised power integral of p of x dx. So that's just the formula. So the reason why we needed to compare these two is so we can actually determine what our px is. So in this case is what? Minus 2. So this is our y prime. Our px is the one in front of the y, which is minus 2. Comparing these two, and our y and our x, q of x or q of x is this. But we are not so interested in q of x, but majorly p of x. So the idea is just to get every other thing that is in front of y, not y bar, front of y, and put it in this formula. So we'll be having exponential of, let me bring down my hand a bit. So the exponential of minus 2 dx. And whenever we integrate a constant, we know that we're going to be having minus 2 what? X. So integrating a constant means you introducing x into it. So that's what we just did. So this and this is all. So our aim of doing all this is just to get our what? Integrating factor. This integrating factor is quite an important one. It will help us to get our our answer. So after getting this, the next thing you're going to be doing is to, I'm skipping some steps for the sake of speed. So the next thing I'm going to be having is, there are some steps that came before this step I'm going to be writing down. Things like you multiplying your exponential to the whole of this, and then factorizing. The factorization is actually in a differential manner. It's kind of the reverse of implicit differentiation. But for us not to get confused there, just simply we will then write your dx in brackets y. This are what? Constant. This four letters or whatever I've written here, these are constant. Then you then multiply it now by your what? Integrating factor. Now this will equal to your q of x, which is your 3 your 3 exponential raised power x multiplied by integrating factor. So for those who are kind of curious on how this came to be, you can actually browse the step. I'm just doing it for the sake of speed and clarity, so someone will not get lost in the explanation. So the simple thing you just need to do is, after getting your integrating factor, which is this guy, this is our integrating factor, you multiply it to dx y. You introduce your integrating factor and then multiply it by your what? 3, your 3 exponential x, which is your q of x. After doing this, and you notice that if you are to differentiate this guy, that's due to this sign here, if you are to differentiate this guy, the value to give you using your implicit method, the value to give you is actually the answer you will get when you multiply the whole of this by your integrating factor. So you can try that out and actually confirm it. So I'm just jumping a step like I said earlier. So this will give us what? This. So we have succeeded in kind of factorizing or moving all of our y towards one side. We are succeeded in writing this in this form. We have succeeded in writing this in this form. So now from here we can now easily integrate to get our y value. So now we can now integrate this. When we do that, we have that our answer to be, when we integrate the both sides, definitely this will be going up. So we have y exponential 2x is equal to the integral of, when we add this together in indices, when we are to join these two together in indices, since they are having the same this, so we can join their powers together. So we have 3 exponential, this is x minus 2, so we're going to be having minus x minus x. This can be written as what? 3 exponential x minus 2x, which is, so we have written this. Now we multiply it by what? Our dx. So we're trying to what? Integrate this guy. So our aim of doing the whole thing is to kind of make y sort of formula. That's our aim. So if you notice, our y is now on its own. separate from our x. So we can just simply integrate this guy, then divide both sides by exponential raised to power minus 2x to get the value of our y. Now when we integrate our friend here, just this, we're going to be having that our answer is since this is minus here, we're going to be having minus 3 exponential minus x. Let's not forget our constants. So this is our answer. So I can also choose to remove this. So we have that this is equal to what? This. Now I'm going to be dividing both sides by exponential minus 2x, and we have this to be minus 3 exponential minus x. When we're dividing, okay, there's no need for that. Okay, now we can also rewrite this when since we're having our power of minus, so when we take it up, the minus sign we go off. This is indices. When we take this up, the minus sign will disappear. So we are going to be having minus 3 exponential minus x plus 2x and then plus c exponential 2x. You can rewrite this to be minus 3 exponential x plus c exponential 2x. You can also go further to factorize, but that won't be necessary. So we have succeeded in getting the value of y. So this is the actual representation or the actual equation. Now what still remains is we don't know what our constant, our c is, so we need to find that. Okay, now for us to get our c, we are going to be using our initial values. Since we already know we already know our initial values, if we are to put it in the formula, it's meant to be able to still work. So substituting our values, we're going to be having that y, no, substituting the values of our initial condition, we're having that 0 is equal to minus 3 exponential 0 plus c exponential 2 times 0. 2 times 0 is 0. N to the power 0 is what? 1. So we are going to be having this to be 0 is equal to minus 3 plus c, and therefore which implies that our c is therefore equal to 3. Our c is equal to 3. So we can rewrite this formula to be what? Y is equal to minus 3 exponential x plus 3 exponential 2x. So this is when we integrate this is what we get. Okay, so now we have succeeded in doing this. So in case if there's anything that was quite confusing about the video, feel free to drop that in the comments. I will make more emphasis on it in any of the video I'll be making. You actually go further again to actually There are some like terms here, so we can actually write this. Permit me to write this to be 3 exponential x. We're going to be having minus 1 plus exponential x. X. So now using this, let us now find, we have that you can either use this or this. This is just factorizing. You can actually make use of this or make use of this. Whatever each of them, each of them you choose to make use of, will actually still give us the same answer. So let me just make use of this first one. Let me make use of the first one. So y when x is now what 0.2 will then give us minus 3 exponential 0.2 plus 3 exponential 2 times 0.2. Now with a calculator, let us see our answer. Three. Now compare this to our answer we got using Taylor series. You can see that they are the same. Our answer here was 0.11 and over here it was 0.113. This is actually the approximate value. My calculator gave me more than this by approximated. So we can see that Taylor series is right at least to some extent. In our own case here to 3 decimal places, it was right. So when you integrate your differential equation given to you and you factorize your initial values, you get your equation for y. And when we substitute our x value to get our corresponding y value, we got 0.0113. So that's all for this video. Please subscribe to the channel, like, and drop your comment in the comment section. See you in the next video. Goodbye.